Hi everyone, and welcome! Today, we're diving into a fascinating programming technique, how to copy an object without retaining any references to the original, especially using reflection. This is super useful for deep copying complex objects where standard methods just don't cut it. Imagine you have an object with many nested objects inside it. If you just assign it to a new variable, both variables point to the exact same object in memory. Change one, and the other changes too. This is called a shallow copy. Even using memberwise clone often only creates a shallow copy, meaning it copies value types but still points to the same nested reference types. We want a truly independent copy, a deep copy, where every single piece of data is new and separate. This is where reflection comes into play. Reflection is a powerful feature in many programming languages that allows your code to inspect and manipulate other code at runtime. Think of it like giving your program X-ray vision to look inside any object. It can see its type, its fields, its properties, even private ones. To achieve a deep copy using reflection, we essentially tell our program to look at every single field within the source object. First, we create a brand new instance of the target object, ensuring it starts completely fresh. Then, we iterate through all the fields of the original object. For each field, we check its type. If it's a simple value type, like an integer or a string, we can just copy its value directly to the corresponding field in our new object. However, if the field itself is another complex object, a reference type, we don't just copy the reference. Instead, we recursively call our deep copy process on that nested object. This means we go deeper and deeper into the object structure, creating new instances for every single nested reference type we encounter. This ensures that when the process is complete, our new object is a completely independent clone, with no lingering pointers back to the original object or any of its internal components. Of course, using reflection comes with its own set of considerations. It's generally slower than direct assignment or memberwise clone because the runtime has to do more work to inspect and manipulate types dynamically. You also need to carefully handle edge cases like collections, arrays, and potential circular references where an object might refer back to itself or an ancestor. For instance, if an object contains a list of other objects, you'll need to create a new list and deep copy each item within that list. Despite these complexities, reflection offers an incredibly flexible way to perform deep copies, especially when you're dealing with objects whose exact structure might not be known at compile time, or when you need a generic solution for many different object types. It gives you precise control over the copying process, letting you decide exactly how deep to go and which fields to include or exclude. It's a tool for specific situations, not a replacement for simpler copying methods, but it's incredibly effective when you need that true, independent clone. Thank you so much for watching and learning about this advanced copying technique. If you found this explanation helpful, please consider subscribing to the channel for more programming insights and tips. Your support helps us create more content like this. We'll see you in the next